can say definition. In definition, we can have multiple definition on the internet, but I have this three keyword is enough to understand Spark theoretically and practically. Let's say first keyword is general purpose, second keyword is in memory, the third keyword is computation. I can start explaining computation first, then we can go for others too. As we know, Hadoop has three main components. One is storage, one is computation, and the third one is resource manager. HDFS is the storage in Hadoop. Same MapReduce is for computation, Yarn for resource manager. The same structure has been followed in Spark architecture, but this is a replacement of MapReduce only. And also it is flexibility to use storage and resource manager. As you see, in storage we can couple or mount any file system like local file system, HDFS, or cloud native file system like AWS S3 or Azure Blob Storage or Google file system. Only changes there in computation. You see the Spark. Instead of MapReduce, we are using Spark. Also in resource manager, we can use any resource manager available in Apache like Yarn, Kubernetes, or Mesos. Okay, this is the computation difference between Hadoop and Spark. You just need to understand Spark is just replacement of MapReduce, not for storage and resource manager. That's why in the definition we are calling only for computation. Spark is not related to storage or resource manager. Okay, then we can go for the second keyword in the definition, in memory. As we compared with computation, here also we can compare Spark with MapReduce. What MapReduce will do, let's consider you have series of MapReduce from 1 to 5. In each MapReduce, you have to read something from HDFS and write back to HDFS once MapReduce completed. Same for job 2 until job 5. That means let's consider you have 5, then 5 into 2, 10 IOs. Okay. That means for every computation, it should read from HDFS and write to HDFS. Because of this, it's very slow. But in case of Spark, same example we can take. A Spark reads only one time while job starting and writes to storage at the end. In between, in some rare case, it will touch the storage, otherwise it will not. All the computation happen only in memory itself. Let's consider these lazy evaluation and in-memory computation. We can explore these keywords in later sessions. For now, just have some introduction about lazy evaluation and in-memory computation. In-memory means Spark will read all the data into memory, do the computation, then writes end result to storage. That's it. That means in this case, we have used only 2 IOs. First read and last write. That's why we are calling Spark as in memory. Okay. Then we can go for the third keyword called general purpose. Like earlier, we used big high scope for different stuff for data cleaning, querying, ingestion. Those are already dead. Now everyone using Spark for all of these steps. Also, Spark is already available in all other languages. Like let's say we have PySpark, in Python, Spark or in R. Also, we can use Spark with Java and in Scala. So it can the same Spark API can be accessible in all the available language. Not all the available language, like currently in main these four languages, functional programming can say. Okay. Then we can come to the end for the original definition. Okay, what we can say? Spark is general purpose in-memory computation data processing engine. What we can say here? Apache Spark is a general purpose in-memory distribute in-memory computation in this distributed data processing engine. That's it. I hope you have now got correct introduction about Spark. Right? That's it for today's session.